Here's where we are in the governance series. Phase 1, seeing the system, letters 1 to 12, that is complete. We are in Phase 2, designing the system, letters 13 to 30. We completed Stage 1, entering design, letters 13A and 13B. We completed Stage 2, stabilizing the core, letters 14 to 17. We are in Stage 3, seeing clearly, letters 18 to 20. We just completed letter 18C, when the data exists and the organization cannot act. We are now in letter 19A, when the information arrives and no one can act on it. Letters 18A, 18B, and 18C address two conditions of seeing clearly. Signal integrity design ensures the right data is being captured. Governing signal definition ensures the right question is being answered. Both are governance design requirements. Both are frequently absent. There is a third condition that neither of these designs fully resolves. The signal can be captured accurately. The measurement can be precisely defined. The report can arrive at the right desk at the right time. And the people who receive it may still not be able to read what it means. Not because the data is incomplete, but because the distance between receiving a signal and understanding what it requires is a capability the organization has not yet designed. That distance is where letter 19A lives. Letters 19A, 19B, and 19C belong together. Each addresses a different dimension of the same condition. The signal arrives and cannot be read. 19A addresses what happens when the people who need to act on a signal have never been placed close enough to its source to understand what it is telling them. 19B addresses what happens when the people responsible for interpreting a signal lack the domain knowledge the signal requires. 19C addresses what happens when the signal is readable and the accountability structure ensures that the consequence of acting on it belongs to someone other than the person who received it. A technology company had developed an application for large venue environments, convention centers, stadiums, and arenas, enabling vendors to communicate with ticket holders, manage sales, and deliver real-time event information to attendees. The application was growing in adoption. Engineers at customer sites were responsible for installing and configuring it. I was brought in to teach those engineers. In my early classes, I began every session in the same way. I asked each student to introduce themselves, their name, their organization, and their role. In one of those early sessions, a student introduced himself as the programmer responsible for the application we were about to spend the week learning to install. The room changed immediately. The other students, engineers who had spent hours in the field trying to make this application function in real network environments, recognized in that introduction someone they had questions for. The session that followed was not a training class. It was a direct confrontation between the people who built the product and the people who had to make it work in the real world. At one point, I asked the programmer directly, "Do you actually use the application you're creating?" He looked uncertain. I did not wait for the answer. I launched the application and put it on the screen. I asked him to begin configuring a basic element, something any field engineer would need to do in the first hour of an installation. He looked at the field. The field accepted up to 50 characters. That seemed sufficient. But when you pressed enter, only the first 10 characters displayed in the list. These configurations used naming conventions that differentiated entries by location and function. For example, if you entered the following into the 50-character field, US.Company.Texas or US.Company.New York, then press the enter key, every entry in the list looked identical. All that was visible was US.Company. All of them showed the same 10 characters. The programmer had built a field that worked correctly from inside the code. The input accepted, the data saved. From a development perspective, the field functioned. From the position of the field engineer, who needed to look at a list of 20 configurations and identify the one for a particular city, for example, Texas, the field was unusable. Every entry looked the same. There was no way to tell them apart. The limitation was not visible from inside the code. It was only visible from the position of the person who needed to use it. The programmer was embarrassed, and the students were enraged. I understood both reactions, and I understood something else. The way that session had unfolded was not useful to anyone. The programmer could not receive what the students were giving him in that form. The students' frustration was real and earned, but the delivery was producing defensiveness rather than insight. The signal was accurate, the container was not designed to carry it. From that session forward, I changed how I handled programmers in my classes. Before each new engagement, I would learn whether any of the students were programmers or developers for the application being taught. If they were, I met with them before the class began. I asked them not to introduce themselves as the programmer. I explained why. Not to protect them from feedback, but to protect the feedback from arriving in a form that could not be received. An engineer who is publicly identified as the person responsible for what is not working becomes a target rather than a listener. The signal that needed to reach them could not travel through that dynamic. Instead, I positioned them as observers, people attending the class to understand how the application was being experienced by the engineers responsible for deploying it. I asked them to pay attention, to listen, to bring their questions to me privately if they had done. What happened in those sessions was different. The programmer who sat in the back of the room and listened to field engineers describe what would not configure, what failed under real network conditions, what the documentation did not cover, was hearing the customer signal directly for the first time, not through a ticket system, not through a manager summary, not through a feature request submitted through an official channel, directly in the room from the people whose job depended on making the product work. Occasionally, a feature changed as a result. A field was widened, a configuration pathway was clarified, a limitation that had been invisible from inside the code became visible the moment someone who had never needed to use the product sat in a room with the people who had. The signal did not change. What changed were the conditions under which it could be received. This is the interpretive gap. The signal was present in every classroom where field engineers struggled with the installation. It was accurate. It was being expressed clearly and repeatedly by the people closest to the consequence. The organization had built a product, deployed it to customers, and sent engineers into the field to install it. And the people who built it had never been required to occupy the position of the people using it. The interpretive gap is not the same as the visibility gap from letter 18A. In the visibility gap, the data does not exist in the reporting system because the system was never designed to capture it. In the interpretive gap, the signal exists and is being generated continuously. The gap is between the signal and the person who needs to act on it. In the proximity, the context and the frame required to understand what the signal means. The governance design had no mechanism that required the people building the product to experience it from the position of the people using it. The programmer was not negligent. The organization had not designed a requirement for that proximity. The interpretive gap was structural, not personal. Interpretive gap. The organization receives a signal it cannot act on because the people responsible for interpreting it have never been placed close enough to its source to understand what it means. The signal is present. The capability to receive it has not been designed. The distinction that matters most for the design response, the visibility gap asks, is the right information reaching the people who need it? The interpretive gap asks, when the right information arrives, are the people who receive it able to read what it means? Both are governance designed conditions. Both have design responses, and neither announces itself clearly because an organization that cannot read its own signals does not know what it is missing. A second story carries the same insight from a different position inside the same organization. As the application grew in adoption and the field complaints accumulated, I began raising the issues directly with the product managers responsible for each version. I described what was happening in the classrooms. I told them what the engineers were experiencing. I gave them specific examples, configuration failures, documentation gaps, features that did not work as designed under real network conditions. The product managers listened. They acknowledged the feedback, and the next version of the application would arrive with the same issues. or different ones, because the feedback had traveled through the same channel it always had, from the field, through the instructor, into a product manager's notes, and then into a development cycle that had its own priorities, its own timelines, and its own definition of what the product needed to do. The signal was present. It was accurate. It was being delivered by someone with direct access to the customer's experience. And it was not producing the response the situation required. I changed the approach. I invited product managers to attend the classes, not to present, not to defend, to sit in the room and experience what I had been describing. The first product manager who accepted that invitation sat in the back of the room on the first morning. By the end of the first lab session, the engineers had identified 3 configuration failures, 2 documentation errors, and 1 feature that simply did not work as the product specification described it. They were not gentle about it. I had told the product manager in advance, the engineers in this room are like sharks when there is a problem with the code. I wanted them to experience that directly rather than read about it in my notes. After that session, they gave me access to the development team. I was able to sit with the coders, work through the specific failures the field engineers had identified, and ensure that the features being built were actually functioning according to what the customers needed. The versions of the application that followed those sessions were significantly stronger. The signal had not changed. The engineers had been generating it in every classroom for months. What changed was the delivery mechanism, the conditions under which the people with the authority to act on the signal were placed inside the consequence rather than informed about it from a distance. The design response: signal translation design. Signal translation design is not about changing the signal. The signal from the field was accurate. The engineer's frustration was real. The character field that could not hold a customer name was a genuine design gap. None of that needed to change. What needed to change were the conditions under which the signal could be received by the people who needed to act on it. Signal translation design is the deliberate design of those conditions. 3 elements define it. Design proximity before the signal arrives. The programmer who sat in the back of the classroom and heard field engineers describe what would not work was experiencing proximity to the customer's signal for the first time. That proximity was not accidental. It was designed. Through a pre-class conversation, a repositioned role, and a deliberate choice to place the builder inside the experience of the user before the class began. Organizations that design proximity before the signal arrives do not wait for a consequence to make the gap visible. They build the conditions, the site visits, the field rotations, the structured observations, the classroom sessions that ensure the people responsible for building and maintaining systems have experienced those systems from the position of the people who depend on them. Change the delivery mechanism, not the signal. The decision to reposition the programmer as an observer rather than the target was not a decision to soften the feedback. The engineers still said exactly what they had always said. The configuration failures were still named. The documentation gaps were still identified. The signal arrived with the full accuracy. What changed was the container. A programmer who is publicly identified as the person responsible for what is not working receives a signal through defensiveness. A programmer who is positioned as an observer, receiving the customer's experience directly, receives the same signal through curiosity. The delivery mechanism determines whether the signal can be received, not whether it is accurate. Place the authority inside the consequence. The product manager who sat in the classroom did not gain new information. The information I had been providing through written feedback and verbal reports was accurate and complete. What changed was not the content of the signal, but the experience of receiving it. There is a distance between reading a report that says engineers are frustrated with a configuration failure and sitting in a room where engineers are demonstrating that failure in real time. That distance is not a distance of information. It is a distance of consequence. Signal translation design closes it deliberately by placing the people with the authority to act on a signal inside the experience that makes a signal readable. rather than inside the reporting structure that makes it summarized. Organizations that build signal translation design into their governance structure do not depend on one person's relationships and persistence to create the proximity that makes signals readable. They design that proximity as a standing governance requirement, built in before the signal becomes urgent, maintained across leadership transitions, and owned by someone with the authority to sustain it. The character field that could not hold a customer name was not a complex engineering failure. It was a simple consequence of a system built by people who had never needed to type a customer name into their own product. Signal translation design does not require new technology. It does not require new data. It requires the deliberate design of conditions under which the people who need to act on a signal are placed close enough to its source to understand what it means. That design is achievable. It is designable, and its absence is one of the more consequential governance gaps in organizations that have invested significantly in building reporting systems, monitoring platforms, and measurement frameworks, and have not invested equally in designing the conditions under which what those systems surface can actually be read. Letter 19A addressed the interpretive gap at the level of proximity and delivery. The signal was present. The people who needed to act on it had never been placed close enough to understand it. Signal translation design closes that gap. Letter 19B addresses a different dimension of the same condition. Sometimes the gap is not in proximity. The people who receive the signal have been placed inside the consequence. They have experienced what the field engineers experienced, and they still cannot read what the signal means because the domain knowledge required to interpret it is not present in the room where the decision is made. Letter 19B asks, what happens when the signal arrives, the proximity is present, and the organization still cannot read what it means? The pattern addressed in this letter, interpretive gap, which resolves to signal translation design. Thank you.